What's up, guys? Now, from what we've done so far, I know you must already be familiar with the concepts of kinetic molecular theory, heat energy, and temperature. You should also be familiar with some of the effects of heat on matter. Now, in this quest, we'll be looking at yet another interesting concept. In fact, what we're going to do in this quest is we're going to combine all of these three concepts that I just mentioned. Now, that sounds unbelievable, but that's what we're going to try and do. We're going to try and unify these three concepts. We'll use the kinetic molecular theory to explain temperature, heat, and the effect of heat on matter. Now, for this lesson, how about we start by explaining temperature with the concept of kinetic molecular theory? Let's start out this way. We said temperature is a measure of the average kinetic energy of the molecules in an object, right? We also said that when an object is heated, the molecules that make up that object absorb this heat and convert it to kinetic energy. So let us illustrate this with one molecule, and then we'll look at the effect on the whole object a bit later. Now, if we assume that a solid object is at a certain temperature, let's say 10 Kelvin, and that the molecules that make up this object are moving or vibrating at a speed of 4 meters per second. Now, let's take those assumptions and remember that we said that molecules possess kinetic energy. And we know that kinetic energy is the energy due to motion. Okay. Now, if we place this object on a heat source, like fire, what we'll notice is that this molecule will absorb heat from this source and convert it to kinetic energy. In other words, the molecule's speed of vibration will increase. Now, as you can see, the more the heat energy, the more the vibration or speed of this ball. So if we now decide to look at all of the molecules that make up the object, then what we'll see is an increase in the overall vibration or speed of all the particles. Again, let's go back to our definition of temperature. We said that a measure of the average kinetic energy of these molecules is the temperature of the object, right? Now, as you can see, the speed of these molecules has increased, indicating that their kinetic energies has increased also. This is how the temperature of an object increases when heated. But then, what do you think will happen if we remove that object from the fire or from the heat source? That's right. The vibration or the speed of the molecules will gradually begin to reduce. They'll gradually begin to calm down as they lose their kinetic energies in the form of heat that is dissipated to the surrounding and to the environment, because there's no source of heat to produce more kinetic energy. So what do you think will be the overall effect of this? That's right. The temperature will begin to reduce. Now, this is why when you hold an iron rod or a spoon that has been placed on a heat source like fire, it gradually begins to feel hot. That's because the kinetic energy is increasing. And when you remove it, it gradually begins to feel cooler and cooler. And that's because the kinetic energy of the molecules is decreasing gradually. Now, that's amazing, right? Now, wouldn't you like to know a bit more about how kinetic molecular theory explains how matter can change from solid to liquid to gas? Now, I definitely want to know. So join me in the next lesson and we'll find out.